Dear students, software testing methodologies, public question, video 4, that is questions from unit 4. In unit 4, most important question is KV charts. KV charts is the most important question. So the KV charts, now we're going to be see. So if you see previous papers, there are different types of questions given from KV charts. Okay, let us start. KV charts. Explain about KV charts for single variable, two variables, three variables, and 4 variables. KV chart. KV chart is also known as Karnavich chart. Karnavich chart. KV chart is known as Karna H chart. It is a combination of Karna and Vich with any one of map or chart or diagram. This chart reduces Boolean algebraic expression. This chart reduces the Boolean algebraic expression. Beyond 6 variables, these diagrams get cumbersome. And other techniques such as the twin MC cluster method is used for beyond 6 variables. These diagrams cannot be useful. So because beyond 6 variables, okay. So these KV chart diagrams are not useful. So that's why we use twin MC cluster method is used. Boolean function of a single variable. The following figure shows all the Boolean functions of a single variable A. For single variable, so what are the different variables? 0, one is 0, second one is 1. 0 is also known as the function is never true. 0 means 1. The function is always true. A, the function is true when A is true. A is true because here 1, A is true, then the function is true. Here A bar means the function is true when A is false. It is known as the function is true when A is false. Next, Boolean function of 2 variables. The following figure shows some of the Boolean functions of 2 variables. How we can write 2 variables functions? See here it is 0, 1, 0, 1. 0, 0, both are 0. That means 0, A bar. Here B0, B bar. So it is called as A bar, B bar. So here in this side, A side is 1. That means it is A. B side is 0. That is B bar. Here in this case, A side is 0. That is A bar. B side is 1. That is B. Here A side is 1. B side is 1. So it is AB. Here in this case, okay. In this case, you consider about this one. This one is on A B bar plus this one is on AB. A B bar plus AB, that is A into B plus B bar. Okay. Now here in this case, how we can consider means this one is on A B bar plus this one is on A. This is A, not A. This is AB plus here it is A bar B. Here this one is on A bar B bar plus this one is A bar B. Here this one is on A bar B bar plus here it is A B bar, A B bar, A B bar. Like that you can write. Okay. Now here in this case, consider about this 1, 1. 1, 1 is nothing but A B bar plus AB plus AB. Again AB plus A bar B. Here it is A B plus A bar B plus A bar B plus A bar B bar. So similarly here it is this one is A B bar plus AB plus A B bar plus A bar B bar. Here it is A B bar plus A bar B bar plus A bar B bar plus AB. Here it is universal false. This one is universal true. So by solving this, we are getting A bar plus B. By solving AB plus AB bar plus AB plus A bar B, we are getting A plus B. Here by solving A bar B plus A bar B bar plus AB plus A bar B, you are getting A plus A bar plus B. Here by solving AB plus AB bar plus AB bar plus A bar B bar, we are getting A plus B bar. Here by solving A bar B plus A bar B bar plus A B bar plus A bar B bar, that is A bar plus B bar. So here it is called universal false, it is universal true. Boolean functions of three variables. The following figure shows some of the Boolean functions of three variables. See here in this case, it is top is A bar B bar A bar B. So it is A bar B, this one, A bar B, and this side is C bar. So A bar B, C bar. Here it is, this is nothing but A, B bar, C, A, B bar, C. Here it is, first one is A bar, B, C bar, A bar, B, C bar, plus A bar, B, C, A bar, B, C. For example, here it is one means A bar, B, C, and A, B, C, and here it is 0, 0 means A bar, B bar, C bar, plus 1, 0 means A, B bar, C, A, B bar, C. Okay. Similarly, next one, Boolean functions of four variables. For four variables, the following one example is given. That is nothing but so here see these 4 ones and these 4 ones. So how you can write for these 4 ones? 4 ones Boolean functions of four variables. Is nothing but see, one means A bar, B bar, C bar, D bar. Here it is A bar, B bar, C bar, D. Here it is A bar, B, C bar, D bar. Here it is A bar, B, C bar, D. Here it is A, B, C, D. Here it is A, B, C, D bar. Here it is A, B bar, C, D. Here it is A, B bar, C, D bar. Okay. To solve about this, writing about first one is A bar, C bar, and second one is AC. Okay. Now, so if you want to bring about this, okay, you just make it into SOP form of A bar, C bar plus AC. That means, so wherever there is no here A bar, C bar, there is no B term and there is no D term. So we write about B plus B bar. There is no D term, then write about B plus B bar. In AC, there is no term about the B bar, B, and there is no term about the D. That means A into B plus B bar into D plus B bar. Now here expand. Now A bar, C bar, B plus B bar means BD plus BD bar plus B bar D bar plus B bar D. Similarly here AC into, you multiply about this BD, B bar, B bar D, and B bar D bar. Now multiply. So first you get A bar B, C bar D. Next one is A, B, C bar, D bar. A bar, B bar, C bar, D bar. A bar, B bar, C bar, D. A, B, C, D. Then next A, B bar, C, D. A, B, C, D bar. A bar, A, B bar, C, D bar. So how you get here this? So total this expression, how we can write here you can write, that is one means A bar, B bar, C bar, D bar. One means A bar, B bar, C bar, D. One means A bar, B, C bar, D bar. Here one means A bar, B, C bar, D. Here it is one means A, B, C, D, like that. So that one, if you go for reverse direction, if you go for reverse direction from this to this, finally it's going to obtain about this one. Okay, that is A bar, C bar, A plus AC. First you can write this by seeing this diagram. Then you can shorten about to this one by taking about these brackets. Okay, right? Otherwise write directly about this. Then you can make it into SOP form. Now next one that is problems. Very important. Problems are very important. Definitely there is one problem. Using Karna map, that is K map, minimize F equal to A, B bar, C bar, D. A bar, B bar, C bar, D bar, A, B, C, D bar, A bar, B, C, D, A, B, D, B bar, C, D bar, A bar, B, C, bar, D. The standard SOP form you write first. So standard form is here, C, A, B bar, C bar, D. No need to multiply any term. Here A bar, B bar, C bar, D bar, no need. A, B, C, D bar, no need. A bar, B, C, D, no need. But here ABD means there is no C term. That's why you multiply with the C plus C bar. Similarly, B bar, C, D bar. Here there is no term A. Then you multiply A plus A bar. Then next A bar, B, C bar, D. Now expand. Now what we get here? A, B bar, C bar, D plus A bar, B bar, C bar, D bar plus A, B, C, D bar plus A bar, B, C, D plus A, B, C, D plus A, B, C bar, D plus A, B bar, C, D bar plus A bar, B bar, C bar, D bar, C, D bar plus A bar, B, C bar, D. Okay. So from this you can write this. Now here what is given? A, B bar, C bar, D is given. A, B bar. A, B bar. A, B bar, where is that? A, B bar, here it is. A, B bar, this one. A, B bar, C bar, D. C bar, D means this one, this one. Similarly, go for A bar, B bar, A bar, B bar, A bar, B bar, C bar, D bar. C bar, D bar means this one, this one. Okay, second term, second term. Now third one, A, B, C, D bar, A, B, then C, D bar, C, D bar. C, D bar means this one, next, this one, next, this term, next, A, B, C, D bar, A bar, B, C, D, A bar, B, C, D, A bar, B, C, D, this one, then A, B, C bar, D, A, B, C bar, D, then this one. A, B bar, C, D bar, A, B bar, C, D bar, C, D bar, A, B bar, A, B bar, C, D bar, A, B bar, A, B bar, A, B bar, A, B bar, C, D bar, C, D bar, C, D bar, C, D bar, this one, C, D bar. A, B bar, C, D bar, A, B bar, A, B bar is this one, C, D bar, C, D bar is this one, Okay, like that you write this. So now this one you make it separate, this one you make it separate, you take 4, this 4 are, and this one separate, this one separate. Okay, this is the required answer. Now go to the second one. The minimize function is now what is the minimize function here? One is nothing but BD, you take common. How you get BD for these two, which is common here. A, B is common, AB. One is nothing but AB. Okay, AB. Then here it is AB, here C bar D, AB, C bar D. AB, D, AB, D is there. AB, for this common is nothing but A, C bar D, A, C bar D, A, C bar D, A, C bar D. Here it is, C bar is there, not written here. Remember, A, C bar D. Then for this second term, second one is nothing but the A, C, D bar, A, C, D bar. A, C, D bar, 2 terms are there. Then remaining two terms. For this one, which is common here, B is common. Here, which is common, D is common. BD is there. BD, and last one. For this both, which is common, A bar, B bar is common. D bar is common. A, B bar is common. D bar is common. Bar is there, but not written here. Now, second one. Minimize the function. So just write about the bars. Okay. Minimize the function using Karna map method. Minimize the function using Karna map method. Okay. F ABCD equal to sigma 1, 2, 3, 8, 9, 10, 11, 14 plus sigma D into 7, 15. Now, in this case, what is meant by sigma? 1, 2, 3? That means, see, you write 0, 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14, 15. After writing these, sigma 1, 2, 3, 1 is place 1, 2 at 2, at 2 place 1, at 3 place 1, at 8 place 1, at 8 place 1, at 9 place 1, at 9 place 1, at 10, 11 place 1, 1, then at 14 place 1, then sigma D 7, at 7 place D, then at 15 place D. Now take common, these two you take one, these two you take one, this 4 you take one, this 4 you take one. So now you write the answer. For all these four, okay, what is there for all these four? That is A, B bar, for all these four. For all these A, B, here it is A, and here it is C, AC. Two terms are over. Now for these two, what is there? A bar, B bar, D, A bar, B bar, D, A bar, B bar, D. And for these two, that is nothing but A bar, B, A bar, B bar, A bar, B bar, C, A bar, B bar, C. Just write about the bars. Okay, very important. So to take the common, that's all. See here, this 2, 1 means what is the common? A bar, B bar is there. This 2, what is common? Here 1 is there, here 1 is there. So therefore D is there. For these two, what is the common? Common is nothing but A bar, B bar is common. Then next one is C is common. You write C. For this 4, in this 2, what is common? A is common. For this 2, which is common? C is common. AC. For this 4, what is there? Only A, B bar is there. A, B bar is there. Okay. Just write the bars. Not written here bars. Actually, I write the bars. Now reduce. Here I can bar exactly. Reduce the following functions in Kannada math method. That is F A B C D equal to F A B C D equal to pi into pi 4, 5, 6, 7, 8, 10, 12, 13 plus B 1, 50. So similarly right here, but in this case pi means previously it is not pi sigma. Here it is pi means you take about A bar, B bar, C bar, D. Okay. And put about the zeros. Previously it is put about ones. Now put here it would be zeros. Wherever the 4, 5, 6, 7, 8, 12, 13 places put zeros. 1 and 15 place put about the D's. Now you take this 4, 1 and this 4, 1, these 2, 1. Now what is the value? The value is nothing but all these fours which is common here. B bar is common. And here it is B bar is common. That is B bar plus B bar. So quite opposite. Plus here to put. Previously it is into, but here it has put plus. First term is over. Now come to the second term. In this term, which is common here, A bar, C bar, D bar. A bar. Here it is A bar is there. For this one A bar is there. Okay, but here 0, 0 is there. C bar, D bar is there. That means C plus D. This term is over. Now third one is for full. This only you have taken A bar. 0 means A plus B bar. A plus B. Okay, we're getting about this answer. Now specifications. Next topic is known as the specifications. Describe the procedure for specification validation using KB charts. The procedure for specification validation using KB charts is given below. Rewrite the specification with consistent language. Rewrite the specification with consistent language. Identify the predicates. Name the predicates with ABC. Rewrite the specification into Boolean and or not. Now the specification is transformed into a set of Boolean expressions. Identify the default actions if any. Enter the Boolean expression in a KB chart and check for consistency. If specifications are consistent, there will be no overlaps. Enter the default cases and check for consistency. Again, if all boxes are covered, the specification is complete. If all boxes are covered, then the specification is complete. If the specification is incomplete or inconsistent, translate the corresponding boxes back into English and get a clarification, explanation, or revision. If the default cases are not specified, then translate the default case back into English and get a confirmation. Okay, confirmation. So here again, I'm repeating what you have to do here in this case. That is the procedure for specification validation using KB charts is given below. First point, rewrite the specification with consistent language. Rewrite the specification with consistent length. Identify the predicates. Name the predicates as A, B, C, D, etc. Rewrite the specification into Boolean and or not. Specifications are written into Boolean and or not. Now the specification is transformed into a set of Boolean expressions. Identify the default actions. Enter the Boolean expression in a KV chart and check for consistency. If the specifications are consistent, there will be no overlap. Enter the default cases and check for consistency. If all boxes are covered, the specification is complete. If no box is covered, then specification is not complete. If the specification is incomplete or inconsistent, translate the corresponding boxes back into English and get a clarification, explanation are used. If the default cases are not specified, then translate the default case back into English and get a clarification. How can we perform specifications into the sentences? Write down the different phrases which can be used for words, or how to find and translate the formation of specifications into sentences is given there. Specifications are formed into sentences by using if-then format. If-then format. By using if-then format, if represents predicate, then represents action. Hence, predicates are used by Boolean and or not, and actions are represented by A1, A2, A3. Default action is represented by else. The different phrases which can be used are if, that means if and when, only if, only when, based on, because, but, etc. Then means then, shall, should, will, would, etc. And means all, and, as well as, both, but, etc. Or means either or, and if, then, and or, otherwise, etc. Not means excluding, neither, never, etc. Exclusive or means but, by contrast, conversely, nor, etc. Immaterial means irrelevant, independent of, irrespective, etc. Okay. So now, other than these, some other phrases also exist, such as respectively, similarly, etc. Now we have a specification of the form: if A and B and C, then A1. If C and D and F, then A2. If A and B and D, then A3. Like that. Explain about the ambiguities and contradictions in specifications. The ambiguity occurs when more than one action is activated. The ambiguity occurs when more than one action is activated by many boxes of KV chart. The ambiguity occurs when more than one action is activated by many boxes of KV chart, or any box is empty in KV chart. Let us consider an ambiguous specification that is known as A1 equal to B C bar D bar, you consider, plus A B bar C bar D, you consider, and write into SOP form. Similarly, A2 you take about A C bar D bar plus A C bar D plus A B bar C bar plus A B C bar, write into standard form. Similarly, you take about BD plus BCD bar, write into standard form. Else you consider about B bar C plus A bar B bar C bar D bar, write into SOP form. Here, what you can find here, A1, A2, A3 represents the actions, and the else specifies default case. That A1, A2, A3 represents 1, 2, 3 respectively. Else represents 4. Now represent the specifications as follows. What you can represent like this here. So here in this case, A1 means what is the A1? A B C bar D bar, A B C bar D bar, A1 A B C bar D bar, this one here, 1 A B C D bar. Then next A B C bar D bar, A bar B C bar D bar, A bar B C bar D bar, A bar B C bar D bar, this one 1. So we are having totally four expressions we have taken. Yes or no? So you consider about these. A1 is the first expression, A2 is the second expression, A3 is the third expression, and else is the fourth expression. Now you specify here 1, 2, 3, 4. Where it's going to be occurred? By taking about these values, that is A, B, C bar, D bar, A bar, B, C bar, D bar. By taking these, specify about here. Okay. So first one you are taken about the 1. A2 you are taken about the 2, A3 you are taken about the 3, else you are taken about the 4, and place correspondingly here suppose here if it is A bar B, okay. First one is one means A bar B C bar D bar, A bar B C bar D bar, A bar B A bar B C bar D bar, then A B C bar D bar, then A B C bar D bar, A B, then A B C bar D bar, A B C bar D bar. So wherever the terms will come, there you put about 1. Wherever the terms will come, put about the 2. Wherever the terms will come, put about 3. Wherever the terms will come, put about the 4. Like that. In these different terms, by considering about different terms, by considering about different terms, put about wherever the first term will come, put about 1. Second term will come, put about 2. Third term will come, put about 3. Fourth term will come, put about 4. In this case, the ambiguity occurs in this case of A bar, B bar, C bar, D. A bar, B bar, C bar, D. C bar, D. C bar, C bar, D. A bar, B bar, C bar, D. Because here there is a empty place. This gives inconsistent or contradictory solutions. So here empty space. So this empty space gives about the contradictory and inconsistent or contradictory solutions. There are several boxes that call for more than one action. In AB C bar D bar, in AB C bar D bar, here 1, 2. Okay, this case. So in ABC, both action 1, action 2 shall be taken. But contradictory inconsistent means wherever there is no entry space, there is no entry space. Okay, there is no entry here, there is no entry. This gives about the inconsistent or contradictory. Okay, but some cases, 2 cases, action 1, action 2, both shall be taken. For unspecified default action, do the following. Suppose if unspecified is there, do the following. Number 1, fill explicit entries in KV chart, apply negation for entry chart, provide an equivalent expression as a default statement. If no default action is given, then blank spaces are replaced with 1. See here in this case, you replace with 1. You replace with 1. So that this becomes like this. Here you consider about different cases. So these 4144 one case and 44 second case and 44 last case. Okay, 414 3 cases you have to consider. So finally, the resultant expression becomes, because this 4 cannot consider, this 4 you cannot consider. Okay, because all are 3s here are there here. Only you can consider top 1, bottom 1. So in top this one, in bottom this one you can consider, because 1, 2 is there here because of the reasons. Here take 4 and 4, 4 here, 4, 4. Finally, the expression obtained is for all these 4 cases A bar, B bar, and these two cases here common is nothing but C. Here common is common is nothing but C. Here common is nothing but C. And in this 4 in this 4 what is there? A bar, B bar is there. In this 4 what is there? A B bar is there. A B bar is there. So for this 4 A bar, B bar, this is over. B bar C. B bar C means here it is for this one and this one, which is common. For this one and this one, which is common. 1 and 1. Here it is B bar is there, C is there. So the 0 is B bar, and for this 1 is C. 1 is C. This 0 is 0. You have to consider about 0. 0 is nothing but B bar. B bar. Okay. For this 1 common is C. So C. B bar C. Don't consider A, because for these cases, for these two cases, so which is common? C is common here for this case and this case. Okay. Similarly, for this case and this case, which is common here, 0 is common. Here 0, here 0. That is B bar. B bar C. Now explain about the don't care and impossible conditions. Explain about the don't care and impossible conditions in the logic-based testing. Don't care terms phi or D are the conditions using which logic is simplified to KV chart. Don't care terms, that is phi or D, are the conditions using which logic is simplified through KV chart. the value of phi can be either 0 or 1. The value of phi either 0 or 1, 0 or 1. Consider the following three possible things. Creation of a universal program welfare knowing both the exact position and the exact momentum of a fundamental particle. Creation of a universal program welfare knowing both the exact position and exact momentum of fundamental particle. Knowing what happened before the Big Bang that started the universe. Basically, impossible conditions are used to support the logic. The two types of impossible conditions are the condition cannot be created or improbable. The condition results from forcing a complex continuous one into a binary logical one. Here I am repeating. Explain about the don't care. Explain about the don't care and impossible conditions in the logic-based testing. Don't care terms, that is phi or d, are the continuous using which logic is simplified to KV chart. Okay. Then one more thing is the value of phi can be either 0 or 1. Consider the following three impossible things. Number one, creation of universal program vector by both the exact position and exact momentum of fundamental particle. What happened before the Big Bang started the universe? Basically, impossible conditions are used to simplify the logic. The two types of impossible conditions are the condition cannot be created or improbable. The condition results from forcing a complex continuous one into a binary logical one. Logic simplification. The steps involved in simplifying the logic are as follows. Identify all impossible and illogical cases. Next, get these cases effectively. For this purpose, you can use about KV charts. In KV charts, fill possible and impossible cases. Use the symbols by which is to be taken 0 or 1. Which is to be taken 0 or 1. Now here, this one, let the following KV chart here. Okay, by taking possible conditions, the function is, what is the function here? For this 4, what is the value? C d bar here. For these two cases, one is C common, one is B common, CB, BC. So like that you write for this. Similarly, let the following, this one, you have to take about the phi and replace. Impossible, by taking impossible conditions, the function is, for all these 4, you can consider one, that is A bar. For all these 4 condition 1, that is nothing but the C plus A bar. Okay, it is multiplication, it is addition. Okay, now we can write about the control flow graph for expression AC plus BC plus for this AC plus BC plus CD bar plus A bar B bar plus A bar B bar C bar D. But this you write this. Okay, so how you are written here? You take, because AC. First one is C is there, then A is there, AC 1 over. Then BC, B is there. Where is B? C is there. BC, B is there, then C is there. B is there here. B is there here. C is there. So where you can find about the BC? Find out. BC should be come here. BC. B is there, okay, B. Then C, where should come about the C? C, A is there, okay, C A is there over. Then C, B, after B then C. CB or BC? CB or BC? Okay, CD bar, CD bar. C is there, C D bar, D bar, where is D bar? D bar here, D bar here. A bar, B, D bar, A bar over, B is there over, A bar over, B is there over, then there is a D bar, E is there is a D bar, A bar over here, A bar, B, D bar. So here it is, A bar, B and D bar. A bar, B bar, C bar, D. A bar, B bar, C, A bar, B bar, C bar, D.
A bar is there, B bar is there, C B bar, C bar D, C bar D, A bar is there, B bar is there, C bar D, A bar is there, B bar is there, D bar is there, D is there, T is there, T is there. So C bar is there, A bar is there, B bar is there, D is there. Okay. So like that, compare about this one, and here how we are written. So from starting, what is there here? A bar, B bar, C bar, D. C bar is there, A bar is there, B bar is there, D is there. Like that. Okay. This is for A bar, B, D bar. So A bar, B, D bar. Otherwise, we make it into standard form, check it. That is very simple. If you have difficult by taking directly here, by make it into SOP form and check it, then you can easily pick it. Okay. Without any problem. Like that, you can solve this. Okay. This completes about the KV charts and this unit. Okay.